today we are looking at a full paper from February-March 2022, and this is Pure 1 Mathematics. In our first question here, we've been given f of prime x for our function, so now we'll integrate it. So you add 1 for the exponent, and then carry that down and divide. So you just do that for those first two, and then we'll put in our plus c. So integrating with indefinite integration, we have an unknown constant of integration. You could think of c as the y-intercept in a graphical sense. So now we'll simplify. 2 divided by 2 over 3 is 3. You can use your calculator for these kind of things, of course, during these exams. So once we've gotten this part, we have another part where we're given f of 8 is equal to 5. So 5 is equal to our function, and replace x with the value of 8. And from there again, use your calculator, and you'll find the constant of integration, which is c. And at the very end of that question, just make sure you write out the whole function or equation again. So our final answer, once you get c is equal to 5, is 3x to the 2 over 3 minus 3/4 x to the 4 over 3 plus our constant of 5. We are given an equation for a curve and a straight line. We've defined a set of values for c, and we know that the curve and line intersect at 2 distinct points. So they intersect, so at that point they meet. So of course make them equal to each other. And then we're going to bring it together, so we bring together our like terms. So variables and constants will go together in a certain way. Just remember, with quadratics you have ax squared plus bx plus c. So you want to do it in that fashion. We're also given 2 distinct points, so we know we have to use the discriminant. So we're going to do that next. I'm now just factoring in those parts to make it easier to set up. So 2c minus 4 was b, and 4 minus c is the value of c for the discriminant. So 2c minus 4 squared minus 4 times 1x squared, times 4 minus c is greater than 0. So our discriminant, when we have 2 distinct points, we have 2 points at the x-axis. They're roots. They cross the x-axis at a certain point. And then you multiply all this out. 16 plus 16 minus 16 cancel out. Minus 16c plus 4c is minus 12. So we'll end up with 0 as one of our points, and 3. And of course, I'll draw a little sketch here. C is less than 0, and c is greater than 3. And if you're not sure how that works, you can always think about where 0 is. So the set of values for this was c is less than 0 and c is greater than 3. So it's outside along that x-axis there. For our first part of question 3, we've defined the term independent of x for the expansion that you see there. So we're checking what leads to x getting cancelled out. So on the right hand side, I'm just writing in the formula with those parts for this particular question. And you might want to just get used to that, just putting this down and putting in those details to check back this. You'll just get used to it after a while. But here I can see already that I need to put in my second term. And I can see that it will cancel out because we have x to the power of 4. And of course, we have the same for that second part there with 2 over x squared. And if you just think about it, when we write it out here, you'll see the x over 4 divided by x over 4 is 1. So that's what happens with this type of question. So you end up with no variable at all. Our answer is 4,860. And again, it's a bit of trial and error. You've got to just do a lot of questions maybe, just checking that. And using that kind of formula on the right hand side there is useful just to get used to it. There's other ways of doing this where you can just find or in certain ways, but I think just checking that and doing 10, 15 questions, you'll be well able to figure it out then. So we've cancelled x out in that question. Now in the next part we see that original expansion times 1 minus x cubed. So it's like 4,860 times that 1 minus x cubed. We again want to cancel x. I'm using the coefficient for the third, so the x cubed. Again, what is motivating you here is to verify if you can cancel out the exponents for your variables x. So here we have x cubed and x cubed, which is x to the power of 6. And that hopefully will cancel out with a denominator of x to the power of 6. And you can see that that's clear that it does. So we have 20 times 27 times 8, and just be careful, you have also a minus 1 there. So minus 4,320, and so take that away from the original part, you'll get 540. And that's our final answer for that. In other questions with this, you also can equate coefficients. You may check the playlist for Pure 1 Mathematics on my channel, and you'll see another video for binomial expansion with an example of one of those questions where you equate the coefficients. Sequences and series. So the first term for a geometric and arithmetic progression are equal to a. The third term of the geometric is equal to the second term of the arithmetic. I'll write that down. And the fifth term of the geometric is equal to the sixth term of the arithmetic progression. So from there, organize your formulas as well. Always write down your formulas on your exam sheet when you notice what topic it is. The terms are positive and they're not equal. At the end, we must find the sum of the first 20 terms for the arithmetic progression. So there's our nth term, we'd say, for geometric and arithmetic progression. So using those details and putting them in now, we'll end up with AR squared equals A plus D, and AR to the power of 4 is equal to A plus 5D, once you simplify it out. The problem from that point is that we have too many unknown values. We have AR and D. You can try and solve it simultaneously. So we're trying to find in terms of A. And one way you can do this is if you take AR to the power of 4 equals A plus 5D, so our second equation, if you will. If we multiply that by A, we can get a common set of terms there. So we'll end up with A squared or to the power of 4 is equal to A times A plus 5D. And then you can simplify that. And if we simplify it a certain way, we'll factor out the square, let's say. You'll get AR squared, in brackets, to be squared, is equal to A squared plus 5AD. So that's what I'm talking about, the red part at the top here. So now I'm putting that in, and you'll see that then we can simplify it a bit more easily. So we only have two unknown values, which is what we want. So AR squared is equal to A plus D, so we replace that in that red second equation. So AR squared is replaced with A plus D. So we end up with A plus D to be squared is equal to A squared plus 5AD. That part is pretty significant. That's a pretty hard part to figure out, to equate that together. Multiplying it from here is probably straightforward enough. You can cancel out your A squares there. Once you've multiplied everything out, you'll end up with D squared minus 3AD is equal to 0. Again, factor out your D. So D is 0 and D is also equal to 3A. So D equals 3A. And we're doing this in terms of A anyway, so now I think we can get to the final part and find the sum for the 20 terms. So 20 over 2 times 2A plus 20 minus 1, so 19, times 3a. So d is now 3a. So our final answer is going to have an a in it. So we get 20a plus 570a. 10 times 2 is 20, yeah. So the sum of the first 20 terms for the arithmetic progression is 590a. Okay, question 5. Express 2x squared minus 8x plus 14. So complete the square. Just be careful of the brackets here. You could do it, you could kind of do it out and then put the brackets around it, but you want to be just careful and just make sure that. So you're 14, you might change it to 7 immediately. It's up to yourself in that way, just to check that. So make sure that constant at the end is inside the bracket or outside, depending on whichever way you're going to do this. Just make sure you don't make that mistake. So when you use your formula for completing the square, you'll end up with like 2 times 4 is 8. So we're already factoring that out. So 2 and then x minus 2, so it's 4 over 2. And of course the second part there will be 2 squared, which is 4. So minus 4 plus 7. So finally we get 2 bracket x minus 2 squared minus 4 plus 7 is plus 3. And make sure you have the wider bracket there as well. That's part A, completing the square. The second part, we're given the same function g of x, and we also have f of x, which is x squared, and they're all real numbers. We have to describe the sequence of transformations. So essentially, we're taking the answer from our first part in question 5. It often might say hence, or give you a certain kind of a indication that the first part is leading to the next part. So the transformation, just be careful here in terms of what you're doing. Just look over your horizontal and vertical rules for transformations. You could think of BIDMAS if you want, maybe that helps sometimes, but the consistency is that, you know, the y transformations are kind of straightforward, and with your x ones you need to be careful. So there's 2 translations, 2 units right and 3 units up, and then of course we have a stretch. The stretch is a scale factor 2 in the y direction. So just think of anything outside of brackets as affecting the y coordinates in that way. Here we have our first of 3 questions to deal with circle equations in some way. So we're given a line of y equals 3x minus 20 and an equation for our circle, and we have to find the coordinates of a and b. So they intersect, so make them equal in some way. So of course we'll replace our y value with 3x minus 20, as you can see. And then multiply everything out. So I've replaced the y in the circle equation with the 3x minus 20 from the straight line. So equate or put together your variables and constants, and you end up with 10x squared minus 130x plus 400. That's easily divisible by 10. X squared minus 13 plus 40 is equal to 0, so 8 and 5. So your x coordinates are 8 and 5 in whatever order you want, 5 and 8. And then you can substitute it back into the easiest one, I suppose, the straight line equation. So you'll get y is equal to 4 for 3 times 8 minus 20, and y is equal to minus 5 from 3 times 5 minus 20. And if you're still not sure, just check with your graph and think to yourself, which one, A or B, which one would be 8 and 4 and which one would be 5 and minus 5? It should be clear that B has a negative value, so it's 5 for x and minus 5 for y. And always write your values at the end as well. So you've calculated it as it's stated. You've done it by calculation. For part B, we find that y equals 3x minus 20, our straight line equation, has now become a tangent. So we have to find a new equation for the circle. So I'm now going to cut to a change in the diagram. As you can see from the diagram on the right, we have a center and our circle has got smaller. So if it's clear, hopefully you can see that because A and B are equidistant, as you might expect, you can find the midpoint for AB. So what's happened here is our straight line has become a tangent, so our circle has become smaller. We found our midpoints, and then you can plug them back in to the circle. So we've a circle equation of x plus 1 squared plus y minus 2 squared equals r squared. Our radius will change. So plug those values in, and we'll get that. So the radius is changing, and once we've calculated the radius, we can just write the whole thing then at the end. So we're going to write out our new equation of the circle. Okay, so we've 13 over 2 plus 1, square all that, plus minus half minus 2, square that, is equal to r squared. You can simplify it all again, or you can just jump to the next step like I will, but 13 over 2 plus 1 is 15 over 2. So 15 over 2 squared is 225 over 4. And minus a half minus 2 is minus 5 over 2. And square all that, you'll get plus 25 over 4. So from there, just put it together, and when you square it off, you can simplify it as well. So 250 over 4 is 125 over 2, and then you'll get square root of that. So the root of 125 over 2 is your radius. So x plus 1 squared plus y minus 2 squared is equal to 125 over 2. And that's question 6 completed. Next one is a fairly expansive looking trigonometry identity. On the right hand side, I've written out our relevant identity, and now we're going to multiply across as you do with these types of questions. So we have to equate this to 4 over 5 cosine squared theta minus 4. So there's a lot of detail here. So just multiply everything across, and then we have our base, which will be cosine theta minus 2 sine theta times cosine theta plus 2 sine theta. So two middle parts will cancel out there. So we should end up with cosine squared theta minus 4 sine squared theta on the denominator, eventually maybe. So I'm going to do that in a bit. So multiplying all those parts out, keep your minus sign there as well. Once you've done that, we can simplify things out. So we have 2 sine squared theta plus 2 cosine squared theta. Of course, that means 2 times 1. So just have a look at the trig identity on the right hand side that I have in green, and you'll see those two parts. I'm also highlighting, putting a box around these bits as well, so it's extra clear for you. And from there, of course, as well, with the numerator, we can cancel out our sine theta, cosine theta as well, and our 4 sine cosine theta, they also cancel out. So we end up with 2 plus 2 as our only part on the numerator. And there's one last little trick. We're going to change our 4 sine squared theta on the denominator and make it into 4 times 1 minus cosine squared theta. So kind of a rearrangement of the trig identity that we have in green. And that's how that question is done. 4 over 5 cosine squared theta minus 4. Hence indicates that we're using the answer in part A. So that is equal to 5, and we have a range there as well. We'll look at it in a moment. So we want to get cosine on its own, cancel out your terms, simplify it in whatever way you can. So we end up with cosine is equal to root plus or minus 24 over 25. And get your calculator out, and you'll get that to be 11.5369 ... 11.5. And from there you can draw a graph. Now you're going to know that the cosine value 11 would also be, like, go back a bit on the graph, like minus minus 11. And it's also maybe going to be another part. So just draw the sketch or use your CAS system, whatever way you want to do it, and make sure. So you can see there's another part there where it's 11.5369 taken away from 180. So our two values will be 11.5 and 168.5. On to question 8, where we have our second circle equation type question. For A and B, we've defined, just like the earlier question, by quick calculation, find the coordinates of A and B. So A is on the y-axis, so we know that x is 0 there. If we find that value, of course, the y value for A and B will be the same. So let's plug that in. So at x equals 0, you'll find minus 2 squared plus y squared is equal to 8, so y is equal to 2. Okay. And from there, we must also find the x value of b. Yeah, okay. So again, plug that into the equation of the circle. And we'll get x squared minus 4x plus 4, multiply it out, plus the 4 equals 8, or you can get minus 8 equals 0, we can do it that way. X squared minus 4x equals 0. And we can factor then as well. So moving forward, we'll get x to the x minus 4. So x is equal to 0, and x is equal to 4. So we can plug that in there. So b is 4 and 2. So there are final values for A and B, the coordinates. Find the volume of revolution for the shaded segment about the x-axis. So around the x-axis, so pi, and integrate y squared here. We're already given y squared actually. So the equation of the circle is x minus 2 squared plus y squared equals 8. So we just rearrange that to get the y squared. So that's our shaded part. That's okay. But there's more to this question now. You'll have to look at the diagram. So I'm going to draw on this now. We have the shaded part on top. And if we had looked at this in terms of a volume of revolution, think of it as a 3D shape in a way, we have something in the center here as well. What would that be? Now there is a way of looking at this in terms of discs and washers and so on, but just to make it clear, we'll just say it's a cylinder we have here. That's what we're dealing with. And the volume of a cylinder is pi r squared h. So that's going to be part of our calculation here for the setup. So we'd have pi, and then you'll integrate 8 minus bracket x minus 2 close bracket squared, and you'd also subtract the volume of the cylinder to find the shaded region, or the shaded segment is what it says. Also take note where our boundary was. It went from 0 at the y-axis to 4. So our x value for b was 4, if you recall. So our boundary is 4, 0. About the x-axis. Sometimes it's about the y-axis. You got to be careful in terms of where it's rotating, we'll say. So integrate that, minus 16 pi. From there you can put in your values. So we have a boundary of 4 and 0, plug them in. So leave pi out the front, it's fine there. Everything is in terms of pi, is a constant. So 8 times 4 is 32, minus 4 minus 2 over 3 cubed is 8 over 3, minus 0, minus 8 over 3, that stays the same, minus our 16 pi. I'll just do that again there. Simplify those values. So the shaded part minus the cylinder is our volume. And again, just factoring in there, so pi 80 over 3 minus 16, you'll end up with 32 over 3 pi. That's your final answer for that question. Question 9, we're given functions. And we're given 3 functions and some restrictions for them. We've to solve the equation f of x equals 0. So that's the first part. So x minus 4 to the root x plus 1 is equal to 0. We want to make x equal to another variable. So let x to the half or root of x equal y. So from there you should, of course, be able to find y squared minus 4y plus 1 equals 0. Can you factorize it? Doesn't seem so. So we're going to use our quadratic formula. So minus 4 plus or minus root minus 4 squared minus 4 times 1 times 1 all over 2 times 1. So you'll end up with 4 plus or minus root 12 over 2. You can simplify root 12 as well. So it's 3 times 4, so 2 to the root 3 as well. And we just have to make sure now, we already stated, we've changed the formula. So x to the power of a half, or root x, is equal to y. We have to adjust our values now. Make sure you don't forget that part. So you'll get 2 plus or minus root 3 is equal to x to the half. And I suppose the easiest, this is not too difficult, this particular one, but you can just square each one. So you can square 2 plus root 3 and 2 minus root 3. And you'll get two values then, of course. You'll get 4 plus 3 plus 4 root 3. So 7 plus 4 to the root 3 and 7 minus 4 to the root 3. I'm going to write them out, write out both of them. Just make it very clear. So you've solved the equation and you've given the solutions in the exact form that's asked as well. So that's the first part there. Next, we're given f of x is an identity to g of hx. So we'll do the second part first. Remember that h of x is going into g. So we'll get m times root x minus 2 squared plus n. So we're going to multiply that out. So g of h, so the x, is equal to m, leave it in brackets, x minus 4 to the root x plus 4, close bracket, plus n. You can multiply it out if you want. There's another way of doing this, I suppose. You could equate the original f of x with part of the inside part of that bracket that we had there, but I'm going to factor out, so equating each part. So x minus 4 root x plus 1 was f of x, and we have there g of hx was mx minus 4 mx to the half plus 4m plus n that we just wrote down there, and we can equate it in the way we do the variables. So x we can equate with mx minus 4 root x. We can equate with minus 4 mx to the half, or root x. I'm using root x here, but you understand that x to the half is the same. And then of course 1 we can equate to 4m plus n. So once you equate them, as you can see, I've solved them already on the top. So mx equals x, mx is 1, and the other parts are the same. And you can check back over it, you can make sure they actually make sense by just plugging them back in or substituting back into the functions. Our penultimate question, question 10, our third one with circle equation apparently. So we have radius of 5 around that first circle, and we have a radius of 8 around the second one. If I do a special triangle here, you'll see that the whole triangle is 5 to 13, so it should be 12 on the adjacent. And of course 8 and 4 is 12. We're trying to find the perimeter of the shaded part, so we're going to find the length of the arc for those two parts there that I've coloured in red. We have 4 already for DE. So first of all, we'll find the angle. So sine opposite over opposite over hypotenuse. 12 over 13 is 67.38 ... Second one, angle B, is sine 5 over 13, which is 22.6198. We're going to find now the arc, so the length of the arc for both. So to find this, it's like a proportion of the total circumference, isn't it? So for the first one, angle A, 67.38 over 360 degrees times 2 pi r. So 2 pi times 5. And we get 5.880 ... And for angle B, we'll do the same. So again, a proportion of the total circle is 22.6198 over 360 times 2 pi times 8. The radius of that is 8. And is equal to 3.158. So we can add them together, I think. So that's the perimeters. 4 for DE plus 5.88, which was ACD, the sector there, the length of that arc, and plus 3.158. So our final answer is 13.038 centimeters. Second part, find the area. So find the area of that shaded part. Okay, find the area of the triangle and subtract the sector areas. That makes sense. So the area of the triangle will be half times 5 times 12. Just think about where the right angle is. Minus the area, so the area of a sector is pi r squared, and then the angle. So let's do that for both of them. So subtract both of them from the area of the triangle. And you'll get 30 minus the two of them together is 27.33. So 2.64 centimeters squared, doing area. That's question 10. So on to our last question, where we're looking at an equation. We've got k, so find it in terms of k, the values of x, where there's a stationary point. So that should indicate to us the topic we're doing differentiation. So differentiate that function there, or the equation I should say, and just make sure you use the chain rule on that first part as well. So it's times 3. The inside part is 3 when you differentiate. So we should end up with minus 3k times 3x minus k to the minus 2. You can put the minus 2 underneath. So minus 3k all over 3x minus k squared plus 3 equals 0. Move the 3. You can cancel out the 3 in as well. 3k is equal to 3, so you can cancel that 3 as well on the numerator. And so we get k is equal to 3x minus k squared. And if we want to get in terms of x, you could do it 2 different ways here. You can do the easy way or the long way. So root k equals 3x minus k is the nice easy way, and you'll get k plus or minus root k over 3 when you do it in terms of x. You could have done it another way where you multiply out 3x minus k squared, and you'll use quadratics, you'll use the quadratic formula, and you'll get it that way. It works out either way. If you spotted that, then good enough. Okay, next part. We're actually given now a value for k. So if k is equal to 4, find the value of a and determine the nature. So again, determining the nature, we're going to have to do, we derive it, to find a derivative, and do that again. So x is equal to a. So in comparison, so we have 4 plus or minus root 4 over 3, just based on our answer from the previous question, is equal to 2. And we know that x is greater or equal to 3 over 2 or 1.5. So let's find a derivative and then the second derivative of that as well. Remember to use the chain rule as well, please, in that case. So let's do that out. We'll do it slowly enough now. So minus 1, so minus 12, I think, is the first part. So d over dx. And then we just do that. So minus 12 times minus 2 times 3 is plus 72. And we have to the root 3. So 72 over 3x minus 4 to the root 3. Sorry, to the power of 3. And from there you can plug in your x value. I'm just writing it out now, just going through it. So when you've multiplied that together, you can write it out whatever way you want. But I think putting the 3x minus 4 cubed, on the denominator is just an easier way of doing it. And so x is equal to 2. So you get 72 over 8. And of course that's equal to 9. But our value of 9 is greater than 0. So dealing with determining the nature of the stationary value, of course, is a minimum. That's a rule from your unit on differentiation. That's the nature. Okay. Part C. We're given something similar, but a bit different. K in this case is like minus 1, it appears, as opposed to 4. If you make our reasoning clear, okay, thank you. So we're going to differentiate again. And just a chain rule. So you'll have that 3 as well. So you will have 3 times 3x plus 1 to the minus 2, or again 3 over 3x plus 1 squared is the way I write it. It's more palatable in that way. Plus 3, so the x disappears. So the derivative of gx is greater than 0 at x is greater or equal to 0. So when we're dealing with this, is it increasing, decreasing, or no movement? This is an increasing function. Because x is greater or equal to 0.